Okay, guys, now we're going to start looking at some specific problems about in reference to the hyperbola. So here's our equation of our hyperbola. Well, of course, we know it's a hyperbola because of the difference sign between them. And the first thing we ought to find is which direction does it open? So, and of course, or which type of symmetry does it have about the x or y axis? So we're going to try to identify intercepts. So if I let x equal 0, I'm left with solving a y equals the square root of -4. So that's not contributing any intercepts, so which is fine because it tells me that it's going to open up left and right because it's going to have x-intercepts at 3 and -3. So again, that's my method of determining which direction it opens by finding its intercepts. I suggest the same for you. Okay, so there's my vertices of the hyperbola, synonymous with the intercepts. Okay. Now we look to try to sketch this in with the asymptote line. So if we go back, we can see that I altered the form quite easily to identify A and B simply by dividing through by this constant value over here of 36. So then that identified for me the A as 3 and the B as 2. Okay, which of course is going to allow me to find the lines, the asymptote lines of the form b over ax and negative b over ax to be specifically 2/3 x and -2/3 x. So I sketched those lines in. They are my guidelines, and I have the intercept points at 3 and -3, so I can plot those in, and from which I can come in now and sketch my hyperbola. It seems a little off there. You can see my lines aren't aligned. That's fine. You get the idea. The only thing not shown here is the focus, which you should easily be able to find, which should be at the square root of the square root of 13. Okay. Let's try another one here. Okay. This, you might suspect, is going to open up and down because of the y term being first. Again, we're going to divide by 36, so I can identify my A and B, from which I can identify my vertices and my direction, my orientation of the thing. Okay, also allow me to find the asymptote lines, in this case a over bx and negative a over bx, mainly being 2/3 x and -2/3 x. Okay, so here we go with that, and of course we could have also found our vertices here on the y-axis at 2 and -2. Okay, there's a kind of neat alternate way of constructing these graphs. It's with a box. Okay, I think I mentioned this in a previous video. We just construct this box, and with the box constructed, we use the diagonals of the box as the asymptotes. So let's take a look at a particular example here. Okay, one that we've been looking at. All right, so we have identified our A and B values. Okay, easily enough. And so what we're going to do is we're going to construct a box which is defined by the lines y equals A, y equals -A, x equals B, x equals -B. Or more specifically, y equals 2, horizontally here, y equals -2, x equals 3, x equals -3. Okay? The diagonals of that box are the asymptotes. Okay? And of course, you can see, since we know we're opening up and down here because of the y term being first, and more specifically because we do not have x-intercepts, okay, we are going to find that the slope of this line is basically the height of the box here, which is A. The rise over run, so it's A over BX. And there, of course, then we come and sketch our hyperbola in there, showing that it's contains those vertices points, which are, in fact, the midpoints of the sides of that box, and should carry that out to show that it's driven asymptotically to that. All right, so here we're going to do a completion of the square problem to identify a hyperbola. And so we're going to have to collect our x terms with our x terms, our y terms with our y terms, and that is done right here. We should look to see that the square terms have a coefficient of 1, that we're good with the x, we're not good with the y, so the y term's got to pull out to 9, and of course 9 is pulled out from the 54 to give us 6. Completing the square in x calls for adding 25, so we're going to add 25 to the other side here. Completing the square in y means we're adding 9. No, we're not adding 9. We're adding 9 times negative 9. So we're actually adding negative 81. We're going to put that over here too. Okay. This then comes to this form. You might think it's red flag because of this value of negative 9, but look what happens here when we divide through by it. Okay, we're forced with the y term being first, which is indicating the vertical orientation of this, and the x term being over here. Okay, so we have everything we need now, having gone through that, enabling us to find the a and b, and of course we can see here the center is going to be at in this case 5, negative 3. And we've got the a and b values of 1 and 3 respectively. From that, we can of course construct the graph. Okay, so as we see, the center is at 5, negative 3. We agree that that it opens up and down vertically orientation, and that the vertices can be found quite easily enough, as is indicated here. And I guess from that, we took everything and we were able to construct the graph. Okay, so we constructed the box, having the center there as we saw 5, negative 3, and we came left and right to define our boxes at as we see here, the lines that define our boxes, just going back there a sec, okay, we define our boxes in y, 1 unit above and below the center, and 5 units or 3 units left and right of the center. So so the center here is at 5, negative 3, 1 unit above and below puts us at negative 2 and negative 4. 3 units left and right puts us at 2, x equals 2, and vertical line x equals 8. So that defines a nice box. The diagonals of that box, of course, define our asymptote. From that, we can pretty much construct our graph. We can define our asymptote equations as we outlined for you earlier. They will prove to be as indicated here. Okay, and here comes our graph. Okay, and that's pretty much an all-inclusive problem, working from the expanded form, recognizing it as a hyperbola, finding the critical components of the hyperbola, its orientation, its a and b values, enabling us to find its center, its vertices, and its asymptotes. A good all-inclusive problem. Make sure you can do that. Okay, and there you have it.